Alright, so after a very long time, in March, nearly the spring, I'm back to try and conquer the Advent of Code 2023. One thing before I start the video, for this day, I've seen the solutions, I've seen how some people solve them beforehand, so I kind of know what I'm doing already. I don't have to figure it out as much, so I just want to say this is a bit cheaty. I still have to implement it, and I have a rough idea. I'm sure I'll still struggle. But I have seen the Reddit threads. I have seen how people solve these, so do forgive me for that. But anyways, you finally reach the hot springs. You can see the steam rising. So I'm completely out of touch with the story. Let's go here. Hello, what brings you to the hot springs today? Sorry, they're not so hot right now. We're having a lava shortage. Oh, Olive Gear Island is currently offline. Nothing is being manufactured at the moment, not until we get lava back. Okay. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which spring would even be safe to use. Worse yet, their condition records of which springs are damaged. So the puzzle input is the condition records. You'll need to repair them. Okay, in a giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational. Damaged hash. This is the part of the condition. It's part of the condition record that is itself. Wait, this is the part of the condition record that is itself damaged for some hot springs. It is simply unknown ? Whether the hot spring is operational or not. Okay, there you go. However, the engineer that produced the condition records also duplicated some of the information in different formats. After the list of the springs for each row, the size of each contiguous group of damaged springs is listed in the order of the groups that appear in the row. This list always accounts for every damaged spring. Each number is the entire size of that contiguous group. That is, the groups are always separated by at least some hash operational spring. Okay. Okay, this will be 4, never 2, 2. Yeah, cool. So yeah, we have hash dot hash dot hash 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 113. Yeah, and then I think they go ahead here saying that, yeah, this could be more complicated. One thing that is interesting to note, and let's not start there, but because I know that part 2 will require much more optimization than the first part, is that the dots don't matter, right? Like, you only need one of the dots, so you can actually reduce like a lot of possibilities there already. So I think what to do here is you look for, oh, and leading and trailing dots also don't matter, so this can go, but let's not do that in part 1. We have hash dot hash dot hash hash hash. We can kind of look ahead with the hashes. I'm pretty sure towards the end. So for this one we have hash, then a dot, then a hash, then a dot, and a hash, hash, hash. So we're going to do a recursive function when we get the configuration. And what they want to know for each one is the number of possible range for each row is 1. This one is 4, 1. So there's probably always 1. I think I assume. And you add them all together. So let's take our example. Let's put it here. Okay. So the thing to do first is declare our function recursive solve, and it takes in an input which is const u8. Okay. Const u8. Oh, and then yeah, we're gonna slice that u8. We're also gonna have a config, which is going to be the numbers. So that's going to be an array of the u8. Is u8 enough? 255. Yeah, just to be safe. u16. And I think, we can get this to return like a u size. Do I not need that? No, yeah, it's TypeScript that needs that. Okay. So what's going to happen here is what's going to happen here is, if you're a if dot, right, input 0. Oh, we need our base case, by the way. If input.length is equal to 0, return 0. Oh, not quite. We need to say if it is 0 and config.length is equal to 0, return 1, because we have reached the end. Let's do another if input.length length is equal to 0, and we want to return 0. But there is a chance where you have the input, let's say dot dot dot, and the config is empty, and this is fine, right? But I think I'm going to do this recursive case on the inputs now. So I'm going to say if the input at 0 dot is equal to a dot, then we're going to just do return rec_solve. We're going to take input 1 there. Is that not how you do it? I feel like that's probably how you do it. Oh, 1 dot dot. Yes, that's Go syntax. And the config. Okay. And it's quite important that we create a different memory location there. We can improve this by using like just a counter basically instead of modifying memory. But they are stack allocations here. I'm pretty sure. Yeah, they have to be, right? Because this is Zig, you manage your own memory, so they have to be stack allocations. So it's probably not a big deal, but probably a couple of milliseconds to shave off there. Okay, if you are a dot, you return if the input 0 is equal to a hash. Oh, actually, first of all, let's check the question mark. The thing is, if it's question mark, if unknown, try both. Right? We're gonna go, if it is unknown, we do return rec_solve input 1 dot dot. No, we gotta substitute it. So we have to create our own. God, I don't know. I can't remember how to do that in Zig. We need to create our own array based on an input. Do I need a mem copy? Maybe. Because I can't like just do the JavaScript spread. You know, that's kind of what I'm thinking in mind. So it's just it's got to be mem copy, right? So we're gonna create an array. Yes, we're gonna go new input. New input equals Zig learn. No, Zig learn. Oh, this is new. Yeah, this looks nice. I was using, is it Stockysaurus or whatever it's called? Ah, here. Yeah, so it's gonna be 5. So it's gonna be the length. Oh, does the length have to be known beforehand? I'm thinking it might have to be. And then do that. Oh, I don't know about that. Input.length, where the new input. Oh, we're going to need 2 of those. Dot input hash input dot input at 0 equals dot hash input at 0 equals hash. Oh, and before that we're going to do stand dot mem dot copy. Yeah, so U8, which one is first? First is the destination. Dot input and input. Hash input Now we do that, and then here now we just go dot input config plus rec solve of the hash input and the config. Do you compile? You do, great. But yeah, I mean, we wouldn't get runtime errors. They would tell me to go away. Oh yeah, because it's 0 initialized. Definitely. And then the very last case is if inputs at 0 is equal to hash, because this is the hard one where we actually have to check some stuff. So it will be useful to just see one of those. Actually, I'm going to take the very easy example they give up here. And just keep it there. If we are, imagine that this is actually slightly different. We have 3, 3. We're at a hash, right? And if we are at a hash, we have to match. Oh, okay. So one of the possibilities is that that one works. For example, if we're like here, like imagine from having done the question mark and you end up at an impossible position. You're at a hash and the next, you only have 2 ahead of you, but the configuration says 3. You should return, right? Because you're not going to pop the 3. So like you're trying to get rid of that 3. Okay, so let's make that condition first. Oh, we need to check the number of hashes beforehand. Num of hashes equals 0. For input C, and we're going to go if C is equal to hash num of hashes plus plus, that is plus or equal 1, and continue. Otherwise we're going to break, because if it's not a hash, then num of contiguous hashes. Very nice. I think that works. Ooh, I didn't actually expect refactor LSP thing to work there, because it wasn't implemented last time I tried. Well, I'm glad it is. Well done to the Zig team. Very cool to see the language evolve so quickly. Okay, I think that's right. That feels right. Yes. And now we're going to check if now if continuous hashes is not equal to config at 0, and we're guarded by we're not guarded. We should be guarded, because I think we're relying on like some perfect input, but you will throw here. I might actually panic out of here. If I don't think this will ever happen, at least it shouldn't, because we hold the config, because I think the input is perfect, right? But let's panic. Config length should never be 0. Yeah. Okay. Just a way to see if we're wrong. Okay. Number of contiguous hashes not equal to the config 0. That means it's impossible, so we should return 0 from this function. We shouldn't try anymore. Okay. Now, what else is there to happen? It could be that the number of contiguous hashes is equal to the config. That's just the alternative to this. I see no reason why that's probably fine, right? Actually, if we don't return 0, we should return rec solve. Oh, and we need to pop that number of hashes, so we need to go input. Oh, I'm gonna mess this part up, I'm pretty sure. Number of contiguous hashes dash dot dot. I hope. Yeah, that's probably fine. Yeah, that's fine. And config has been matched, so we go 1 dot dot. Do you compile? We do compile. Okay. Great. Let's just do a test. Test it works. Test basic easy example. So we have var example 1, which is this here, and we go. Oh, we have the expect up there. Expect try. Expect that rec solve. Take example 1 and var 1 config equals underscore of u. What did I take that to be? 16. 1 1 3. Example 1 config. This is equal to 1. Alright, Zig test day 12. Array literal requires address of. Does it? Oh yeah, because it's kind of defined, right? Can I get rid of that? Does not support rationalization syntax. If I do this, it's going to expect array literal requires address of operator. Okay, that's gonna enable to evaluate runtime expression. It is, isn't it? So do I really have to make that a input.length is runtime? Is it? Oh, it's because it's not initializing. Anyway, otherwise I'm gonna need an allocator. Okay. I mean allocate mem dot alloc dot heap, isn't it? Allocator. Okay. So we're gonna have to do is it try allocator dot alloc u8 input dot length. Alloc does give error, right? Yeah, it does. So we need to try. This must now be tried as well. I am recording. Thought I wasn't recording. Mic already there. And now we need to try this. Yeah. Okay. Allocator is not marked pub. Oh no, you need allocator equals standard dot heap dot test allocator, or just page allocator. Yeah, there you go. So is it just standard or allocator? Is it? No. Standard dot mem dot alloc. You put it in mem, but you keep the others in heap. There's probably a reason for that, right? Allocator, and then we need the sample 1. Not that. Oh yeah, now they all need the allocator. Yep. Allocate rec underscore solve. Oh, there you go. What else? Invalid operands to binary. Oh, error. Okay. What is this? 932. Oh yeah. Try. Happy? No. Okay, what is this? Function with non-void return type. Oh, is this down 0 or something? Okay, good. More complicated example. They have some there. Oh, only with question marks. Yeah. All right, let's try this one here. 113. And this one can still only have one arrangement. Okay. That one failed. Why? Why do you fail? Huh. Wait, it doesn't tell me what it is. It's gonna go standard.testing.expect. Can I do that? Expect equals then? Oh yeah, and then the one is a parameter. Hopefully this tells me what goes wrong. Doesn't. Expected 3. Found 1. Oh. Expect 1. Oh, that, yeah, okay. It returns 3, okay. Where's that logic error? Okay. So I mean, print, let's try dot input and hash input, and let's print that's, oh, it's, I need these, don't I? The anonymous tuple. So starts off. Oh, can I skip? I'm just gonna, yeah, get rid of some noise. So it starts off with a hash. Oh wait, what if it's hash and then question mark question mark? Oh yeah, what do we do about that? If it's hash, then, oh yeah. If the next one is a question mark, I could be fairly lazy here, I think, and say if it's a hash right now, instead of counting, thank you, instead of counting hashes, I can reduce the config. Why don't I try that? I'm going to try that. I'm just going to copy that, comment that, because that could be valuable later. I think maybe to optimize we might need that. So what I'm going to do is I'm going to say if you're a hash now, if you're a hash now, I'm not going to count anything. I'm going to ask if config at 0 is equal to 0, then we return 0. Right? This is like the no good input, return early. Otherwise, oh wait, we must Yeah, I must kind of disregard config at some point. So what I'm gonna next one is like bring it down. So I'm gonna say config 0 minus or equal 1, and I'm gonna say if config 0 is equal to 0, we need to pop it, right? And continue. So we need to return regsolve allocator input 1 dot dash dash. If it's 0, we pop this off. Otherwise, we return regsolve allocator input 1 dot dot. But with a new, with just the config still. Is this any good? Feels okay. The thing is, this could be the last. This could crash because input 0 could just have length of 1. Would this just return empty array then? I hope so. What happened? Okay, fail. Okay. I mean, I'd love it if it told me why, but so we do this, then it goes to that, this. Yeah, I mean, sure. Man, it doesn't. Okay, let me just res equals try. Delete find. Delete find close bracket. Put it there, and then res equal 1. And then here I can just go print result res. See what we actually get. Oh wait, I just deleted a bunch of code. No. Oh, expected 0. There you go. Expected 0. You got 0 from that, really? Okay. Let's just print them at the top each time. Print s dot slash input here. Let's do the config as well, and let's print this. Pretty sure that's how you solve it though. What is this? Invalid format string s. Oh, I can just leave it. Nope. Okay, you go any. There you go. Figure it out. Okay. So we get what the hell? Oh, there you go. Oh yeah, there. Question mark. Dot hash. 103. Great. So that's a dot. No, it's a question mark. So it tries being a dot, but we know that that's not really going to work. It's going to go all the way down. Right, and it's going to do a hash. Oh wait, see here. It did 1 hash. It did another hash. Oh, and then it did the 3, and it realized it's not going to happen. And it did 2. Okay, good. So yeah. So then we go back here. It's got a bunch of the zeros, which I don't really think is a bit funny. 0. Is it because I'm modifying some place and I need to do 0 dot there? That's a memory sharing issue. No, if you see that, there's a bunch of these. 0, 0, 2. Mm-hmm. I feel like it's a memory sharing issue. It feels that way, at least. I'm still getting 0, 0. Wait. Okay. Oh, we just returned 0 here. That's saying it was no good. Oh, but this could come. Okay, yeah, this could come at the back of one of the others. So we see. Wait, we don't get the hash question mark one, do we? Hash question mark. We don't. Yeah, we only see hash question mark there. Oh, we see it at the bottom. Right at the bottom. Why is that the last one to print? That doesn't feel right. Dot everyone hash remember brand new, so it doesn't matter. If you are equal to 0, we're going to skip over you. If you're not equal to 0, we're going to go do it again. Surely where it's printing at the bottom, no? Yeah, it seems kind of weird that it reaches this stage here, being 0, 0, 2, already with like 1 decrease from everything. That's pretty weird. Okay. If it's a hash and input 0 is 0, then yeah, it's no good. Is it no good? Yeah, surely. Yeah, it's definitely no good. Let's do new config equals stri allocator.alloc a u16 the size of config.length, and then we're going to do standard.mem.copy u16 the destination new config from config. We're going to do new config there, we're going to do new config here, and just new config here because it doesn't matter, right? So we got the same? Oh no, we got something different. So it was that. Well, something like that. If I do 0 not dot there, what happens? Anything different? No, okay, yeah, I thought so. Okay. So okay, yeah, this makes some more sense. Okay. It is a 0 here. Oh, okay. Wait, no, the 0 reached. Okay, it's printing at the top, so there's a 0 there. That's no. You know, that should just not be a thing. There shouldn't be a 0. Because I guess the one here, with a hash, it finds it, takes it down. If it's a 0, it should... Huh. Why isn't it... Right? Oh, whoa, oh yeah, this check. This check is wrong. Okay, I mean, okay, now we get config length should be not be 0 here. Config length is equal to 0. We could not panic and we could return 0. Because if config length 0 is there and there's a hash left, because that's the only possible thing that's left, right? We could return 0. So, okay, now it resulted 3. wonder which 3 branches. That would be pretty hard to know. And if does this do anything? Okay, if input length 0, then return 0 now. It doesn't. Okay. Hash here. I think I need to really rethink this. Let's get rid of you, get rid of you. I think you're good. Yeah, probably good. Let's get rid of you. I think I'll keep that, and I'll just delete everything inside here. The inside there. Cool. So, one of the problems I was having is that if I had question stuff like this. Okay. Let's start with an easier one. This 3. I take a group, this pattern here, and I check that you are long enough for this 3. And that you don't contain a dot, like for example, that's not allowed. So we take var, the current is equal to config at 0. Now contains dots equals false for input c. If c is equal to a dot, contain, oh wait, no, 0 dot dot current group, right? Index, if the input at I is equal to this, then contains dots equal to true, and we break. If it contains dots, return 0. It doesn't match, right? It doesn't actually match with the current one. So yeah, doesn't match the current one. So this is our hash dot hash points to 3 fixed. I think. Okay. So the next step to think about is, at this point we are guaranteed to only have a thing group long enough with like this type of stuff. For example, hash question mark. For example, 1 1. So this can match. Or let's check this one, for example. If you have that like that. What are the checks needed here? You say, so if check there's no dots. I guess we check if it's long enough. If input.length is smaller than the current, so for example if it's 3 and we only have 2, yeah, return 0. This says like not long enough to match. Yes, I think this is more in line with everyone else's solutions. I didn't see any solution that was mutating something. Maybe there was probably something there, but okay. 2 checks. What else? So eventually we just want to say return recsolve allocator inputs at 0. Oh wait. If we have, oh, okay, there's 2 possibilities here. Imagine you have something like hash question mark. This gives you 3. You want to, because it is a group, you want to slice that last one, right? The next recursive call should be nothing into nothing, because you want to get rid of just one more because you assume that's a dot to break up the thing. And if it wasn't a dot, then it doesn't matter because it's fucked anyways, right? It's not a good one, right? Oh, that seems to make sense, I think. Or if it's the same length as above here, right? So isn't that the same thing though? Oh wait, okay. If input dot length is equal to current, then we return 1. Oh no, sorry, we gotta return, recurse still. Allocator input at the group dot dot and the config and dot dot. But then there's another thing. If the input dot length is not equal to current. Oh, actually, if input dot length is equal to current, we can return early. It doesn't need to because we have the base case at the top. Let's not mix base case down here too. What happens here is that the input length is not the same, so it's slightly bigger. So we're going to chomp this bit here, and we've checked for the smaller case. That's not, so it must be bigger. We're going to chomp that little bit. So we're going to actually go input group plus 1 dot dot because we are kind of, that has to be a dot, and a dot we can skip. Oh, this needs a closing mark. There we go. Use of undeclared identifier group. Really? Oh, current. Didn't call it group. Call it current. There we go. Does that work? Does that work? Does that work? Does that work? Nope. Why? What is this? Out of bounds. Dot dot current. Oh, I guess, yeah. Oh, I guess I can do this check up here first. Because then it will solve that. That out of bounds. Ooh. That worked. Even more complex. I think that's it. I think we got it. Well, again, I did look at solutions, and they gave me this idea. I was just kind of not so up to par with this hash stuff, so I'm not gonna put too much on this one, because you know, kind of cheated, I guess. 3, 2, 1. But anyways, it was really useful to look at other people's solutions. I guess that's part of the learning for AOC. Like, you really looking at other people's solutions is just so nice. Okay, that oh god, that got really balked, didn't it? Okay. Config should be 0, but it's not. Can we get away with returning 0? I don't know where that would happen. I think we've been quite loose with the checks down here. Expect 25. Oh my. Expected 25. If I return 1, do I still get 25 then? 27. So if the entire input length is equal to current, oh wait, but then we're not guaranteed, yeah, we're not guaranteed to be at the end of the config. Maybe that panic is kind of important, to be fair, because it does get us onto the right direction, I'm pretty sure. So we know it doesn't contain dots. If it contains dot, we return 0. Doesn't match. If the input length is equal to the current group, then we do +1 here too. That'll break now. Yeah, surely not. Okay, let's think. Input length equals the current. And we do just return this. Okay, if it's not, if it's bigger. Oh, if it's bigger, what do? We return with 1 chopped after. But that could mean that the config got length. Oh. That's just pretty weird. Must I? Maybe let's check up here. I think now that we're being quite loose with what we throw into the recursive algorithm, we need to be a bit more stringent. So if input length is 0, then we go if config.length is equal to 0, we return this. Otherwise we return 0, that means we still have stuff to go. Okay, next. Config.length is equal to 0. We just continue. We go like rec solve. Allocate input config. This will go on forever though, no? If the config is 0 and the input is not, then we just continue, no? Alright, so the logic was okay. It was pretty good, but it seemed a bit rearranged. Honestly, I just kind of shifted some of the branches. I did add these two statements here at the bottom. So if the input length is equal to the current group, then we should return empty string. If the input at the current, so again, we're just assuming there's question marks and hashes. Not assuming, we're guaranteeing only hashes and question marks, meaning we can get the entire group gone. No like half measures. If the input at the current, so remember the zero based index, if you go just 1 over, and that's a hash, that means we're too big, we can't, it doesn't fit there. Otherwise we do skip over the 1 because you do that check for the hash and then do this, and this passes the test. Let's make sure we didn't break any of the others. I don't think so. Oh god, I just double commented those. There we go. Oh, that's great. Okay, cool. That's the working solution, I think. Great. So yeah, now I have to pass some stuff. So what are we passing? We're passing, and let's just check. Where was it? It was 21. Okay, we're passing on to space. For input line tokenizer equals standard dot mem dot what was it? Split. Is there a split sequence? I feel like I definitely have used this before. Split sequence, the buffer is going to be the line. Shouldn't do 0 there. The delimiter. It's going to be you. Is there an example? Yes, there is. Great. Organizer splits iter. We're gonna go var left side. I mean pattern is splits iter dot next dot question mark, and var config equals splits iter dot next dot question mark. Oh, we need to pass config. We're gonna go conf var. So we're gonna go. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yeah, always an odd number. 1, 2, 3, 5. So 1, 2, 3, 4, 5. So it's gonna be 5 divided by 2. Integer divided by 2. So 5 divided by 2, 2 plus 1. Yeah. That's it. So we're gonna go var. Oh, we need an allocator, don't we? Allocator equals standard heap dots page allocator. I haven't played around with the differences, to be fair. The page allocator has always just seemed fast enough. The speed, like, of the algorithm very much depends on me, not on the allocator, I think. But it would be cool to play around. So we're gonna go var. Number config equals standard try allocator dot alloc. We're gonna go for U16s, did we say? It's definitely overkill, but and it's gonna be config dot length divided by 2 plus 1. Cool. And we're going to go var num oh, we don't need this. Oh yeah, we do. Num. Oh wait, no, length. What if it's 10? Oh god. Are there any double digits? Being pretty lazy here. Yeah, 10. Yeah. So you're gonna have to make not very much guaranteed to have. I could just say, like, make a buffer, right? So I could say 100, and then it's never gonna happen, right? Maybe for part 2, not for this one. 100's definitely overkill. Let's go like 20. And let's go. We do need split of our comma iter start mem dot split sequence u8 line comma iter dot num Oh, we're gonna var used use size 0. We're gonna go use plus or equal 1. We're gonna go number config at we're gonna increment used after equals try standard dot fmt dot pass int as a u16 the number. What else do I need? Oh, is it a base? Yeah, base 10. And then we're gonna go. Where are we? 11 up var part 1, which is a use size plus 0. Allocator. The input is going to be the pattern and number config going from 0 dot dot to the used, I think. Oh, we don't want to split on the line, we split on config. Okay, sig run main. Oh god, okay. Oh, try. Yeah. Part 1. Putting on. Correct. Awesome. Oh, that was a long day, and I knew the answer basically. I knew roughly how to solve it. Yeah, just difficult. That was kind of slow, which makes me scared for part 2 that we haven't even done, bro. Okay, good. Okay, as you look at the field, you feel there are way more springs. When you examine the netcode, you discover that they were actually folded up this whole time. So yeah, I think I know what part 2 is. To unfold the record on each row, replace the list of spring condition with 5 copies of itself, separated by question mark, and replace the list, the contiguous group of damaged springs with 5 copies of itself. With 5, oh my god, I just clocked. Oh man, no. Yeah, it's gonna be enormous. Yeah, huge. This is where like the trailing dots and the leading dots. Okay, those probably wouldn't do much effect. You definitely want the middle one shredded though. Oh, but I wonder how fast it is without it. So we can do. Okay, we need 5 copies. So I'm just gonna make an array list of U8s and an array list of config numbers. Yeah, so we're gonna go, and we're not freeing any memory. That's great. I just realized we're not freeing anything. Yeah, we have many memory leaks going on, but yeah, it's okay. Let's just save part 2 inputs, part 2 pattern equals standard dot array list of U8 dot init with allocator, and this init, yeah, okay. Now what's going to happen is we're going to go part 2 pattern dot we're going to have to do this a couple times, yeah. So we're going to go for pattern C. We're going to do this 5 times, don't we? 0 to 5. Yep. There's actually like some copying you can do here. Like if I don't know actually. Yeah, you definitely can do some pointer arithmetic and do some copying. But anyway, so we go through the pattern and we go for each one. We go. Maybe it doesn't add it into menu. Pattern dot. There we go, underscore. Maybe there's a part 2 pattern dot add. Add many. Add many as slice. What are you? Resize array. Add n new elements to it. Add many. No, let's just go. Part 2 pattern dot add. Oh, dot append. Ooh, oh, there's the method I was looking for. Append the slice names to a list. Yeah. So yeah, now we just need to say pattern. And we do that 5 times. And we do something very similar. Part 2 config standard dot array list of U16. In it with the allocator. Yeah. There's a lot of optimization you can do here. definitely a lot. So we're going to add the config 5 times. And config. And then at the end, we're going to go part2 equals try rec solve the allocator with part2 pattern.to own slice. I'm going to try that. And we're going to go try part2 pattern dot part2 config dot to own slice part2. Error is ignored. Oh yeah, fair. Good compiler. Part2 gives me 0. Okay. Why? Wait, hold on. Maybe I misread this. Oh yeah, I definitely misread this. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself. Oh, separated by question mark. And replace the list of contiguous groups of damaged springs with 5 copies of itself. Separated by a comma. So this would become that. Yeah. Okay, so yeah, I definitely misread that. We don't need to do anywhere near as much as I thought, I guess. We need some, but you know. I think yeah, let's get rid of that. Just no need. There we go. Okay. So yeah, we have the number config, we have the pattern, we're just going to need to add it 5 times. So, actually, I'm just going to use the array list still to append strings. Otherwise, I have to do pointer arithmetic, which isn't very difficult actually. But let's see what standard.mem.copy. Oh yeah, it doesn't really. If the argument's not overlapped, what is that? Yeah, mem copy. Yeah, no, not really. Okay, anyways. 5 pattern equals standard dot array list of u8 dot init with the allocator. And we're gonna go 5 pattern dot add. Oh, not append slice try. We're gonna append the pattern 1, 2, 3, 4. And we're gonna do the same for 5 config, but UREU16. And we're going to go 5 config number config appended part2 plus or equal try rec solve allocator try 5 pattern dot to own slice try 5 config dot to own slice, and there we go. Oh, this still gives me 0. What the hell? Okay, let's say 5 pattern slice equals try 5 pattern dot to unsliced. I'm going to go 5 config slice equals try 5 config to uns. Oh, I forgot about. Hold on. Yeah, I forgot about this. The question mark separated by question mark. Right. 5 config cells separated by question mark. Yeah. So each time I go here, I have to say try append hash. How about now? Do you work? Oh, yeah, hold on. Ah, no, not you. I need to just replace the hashes by normal everywhere. Cool. Oh, you still gave me 0. Okay. 5 pattern slice. Config slice. There we go. Okay, the first line will become that. Oh, it's not a hash. Oh, okay, wait. Random jump. Okay, still nothing. And nope. Just print. 5 pattern. 5 pattern slice. 5 config slice. You know, that doesn't seem correct. I think that top one is correct, but so I'm just gonna take this and go. Oh, is this? Ah, wait. Yeah, number config can't be. It's not number config. It's number config. 0 dot dots. Yeah, used. Yeah, I mean that's reassuring, right? A little bit. That's okay. Still not perfect because still pretty weird, but okay. Okay, that's still that first line. Let's make sure that this. Let's take this whole thing here. Oh, we added a question mark at the end, but we don't need to. Maybe that changes something. And that does change things. Okay, perfect. So that was already slow. Okay, no, okay, we have working code. Code works. How long is this gonna take? I'm just gonna do a progressing ... Yep. Alright, let's do it just before we let it go. So we can stop it, man. we can definitely use all 12 cores on this. It's processing that 3. How many are there? 1,000. Great. Okay. So just kind of. Oh wait. Oh god. I think our lack of memory management has really come back to hurt me now. Oh, it definitely has. Oh, kill it. Die. Yep. That was blowing up RAM, wasn't it? That was eating a lot of RAM. Yes, let's let it run again. Okay, so we're at choose 14, 15, 16, 18, 20. Kill. Alright, so we are blowing through RAM. And we are doing so, I think, mostly because of these allocations here. I would love to not make them. And I mean, if we do allocate them, and we do this, are we safe to free? Can we just free it after that? I don't know. Maybe we are. And we need to defer. Allocated, that's free. Dot input and allocated, that free. Hash input. This might break a couple things. I wonder if does this work if I skip part 2? Part 1, 7599. That's not what I got, is it? 7599. Okay, so I can free that. Okay. Let's see, you're a little bit less memory hungry now. Yeah, definitely. But slow. Yeah, very slow. It's like that's the third. It's on the fourth one. Yeah. Like really slow. My God, didn't think it was gonna be that bad. What's so funny about that? The fourth one. A lot of question marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 to the power of 11 is not even that much. 2000. Baby rookie numbers. Let's just double check. Progressing. Like, are we not getting stuck somewhere else? That feels way too long. 1, 2, 3. No, yeah, it's definitely stuck here. It just feels so long, though, for this. There's more question marks up here. That they're like together or something. No, that feels very odd. That feels way too strange. No, it should not last that long. No way. 5 pattern slice. I mean, it's fine. Okay. Let's check. So the one that's taking forever. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 2, 2, 5 times. Correct. And then it's going dot, question mark, dots. Yeah, 1, 2, 3. That's all fine. Must just be a lot of question marks, right? Like there's a lot of them, but it. Oh, alright, let's let it run for a bit. Yeah, I think I'm being a bit silly. The whole point of this second exercise is that it's huge and is going to take way too many cycles. So I clearly have to optimize something. I'm just not thinking very straight, I guess. We have to we have to memorize, of course, yeah. God, oh my god, I'm missing so much today. We have to memorize. If we've seen input or config before, we must, you know, return. Let's say var. Can I initialize var? No. Do I need to pass a reference here? I just want a global variable. Memoized equal memoized, which is of type. Ooh, what are you gonna be? You're gonna be standard dots hash map between. Oh, you're gonna be a string hash map. And you're gonna string hash map between between, actually I'm gonna stringify config because I'm really not, I don't know what that could be, so I can't like do some, I can't like bit shift very well unless I have a massive integer. You're gonna be of type standard. Oh, let's just pass it in. No, let's pass it in. No, let's go variable. Dot string hash map between two. Can I do the array of U8? Yeah, that's probably fine. Girls must be initialized. Undefined. Yeah, so what we're going to do is in main here, we're going to do memoized equals standard dot string hash map u8 dot init allocator. Great. And what we're going to do is, even before we return, we're going to say if memoized dot stringify config. It's going to take in config and review 16, and it's going to take in an allocator standard dot mem dot allocator, and it's going to be what is this going to be? Oh god, U8. Yeah, there you go. Oh, and it has to be a this. So for config number, how to put number. And this is going to need to be above. Oh, I'm once again going to be using just the array list. List equals standard dot array list of u8 dot init with the allocator. It's probably super inefficient for strings, but standard dot fmt dot format int value. What do you do? Sig int to string. How to convert numerical types of a string. Alloc print, what is that? What do you do? Alloc print. How to convert integer to a string at comp time? No, that's not what I want. Can I pass an integer to a string in Zig? Yeah, probably what I want. Ah, it's the other way around. This looks better. Your best bet is FMT content print. FMT dot, maybe I can just do, can I do print? So alloc print takes, man, what? Hold on, I'm gonna just go look for it. It is the day after, and I finished off trying to make memoization work, and I'm just being silly. I'm not even doing it properly. What I'm going to do is I'm going to get rid of this string configuration stuff, and I'm going to use some form of integer encoding. So the thing is, not only do I need to look after configuration, I need to look after inputs. Those both have to go into a key, the inputs and the config. So the best thing to do, I suppose, is to take the I think we could make config U8. None of them seem to go above. Yeah, I think we could change this to be U8 and make it. This what I'm gonna do is I'm gonna get rid of all this memwise stuff. Right? No more memoizing. I just want the the original values. There you go. Off with you. You still have this string hash map, and it doesn't return a use size. This should just be true. Like, it should be Boolean, right? Because you just want to know if what its value is. Like if it does return. Oh no, you do want use size. You want to know how many it returns. Yeah, that's right. Okay, cool. So we have that, and let's take a look at let's get this back, our example inputs, and let's run part one. I need to go into here, the pass into U8. Number config to be U8. Oh yeah, this was pretty weird. I remember wacky. I was so tired. But okay. There we go. Part 2, trying to solve it as well. Let's get rid of part 2 for a sec. Run part 1. That gives me 21. Oh well, part 2 is still really slow. Actually, let's just try just a couple of these. Let's try this one here. Just that one. Make sure it's all still good. I mean, nothing's going to change because the numbers here are small. 16,384. Okay, good. That's all good. Let's keep it there, and let's actually memorize stuff now. Okay, making that a U8 makes things much easier because what I can do. Oh, actually, no, this not you. I was going to say, why didn't that should have been an error? Delete around. There we go. What we can do is we can make a string. Yeah, there we go. So we're going to make input config is equal to standard.mem.concat copies each t from slices into a new slice that holds all the elements. Okay. Oh, great. So what we can do is make allocator plenty of U8. And okay, so we're going to need var input config array, which is equal to an array of 2 of arrays of U8, which is going to be input and config. I think that should be okay. Input config array. What we're going to do is we're going to defer allocator dot free input config. Hopefully. What happens if I do that? Oh, it doesn't like it. What if I get rid of you? Yeah, it's gonna need the adjust operator to get rid of const. Cast disregards, yeah. Wait, what if I just do U8 here? Pattern. Okay, this was all the way down here. What if I do just that? Pattern. How does one disregard this? So what if I do at dot, or if I do dot pointer dot star? No. Yeah, I can't remember how to. Okay. What if I then change the problem to be const U8, and config isn't constant, but I think the alright, that's fine. And then this is going to be a try as well, right? Yeah, so try. Okay. Good. So sorry. Next thing we're going to do is we're going to say if an input config is memowise dot get the input config num turn num. Okay, wait, what was this? Num dot I think this is correct. This is compile. Yeah, like we can do a capture group on num. Yeah. So let's not do these lower level ones, I guess. We can just worry about these. So if we reach this, then we go memowise dot put the key, which is input config with a response. Does put require a try? It does. Same thing here. And same thing. Oh, where are we? Same thing here. And same thing here. Okay. Do you compile? Whoa, okay. Oh, it's segfault. What if I don't free? Just to see what would happen. I can't tell if that's terrible. Or do I actually have to keep them initialized? Yeah, I might have to keep it initialized. Alright, let's hope I don't blow up my CPU. 525152. Oh god, how much memory are you using? Oh, not much. Not much. I thought it was going to be way more. Great. And did that work? Okay, let's go. Yeah, cool. So I kind of had to reverse the problem a little bit there and create arrays of U8 so that I could use just the primitive of string hash array. Sorry, string hash map. That makes things a lot easier. It's really good how fast that is actually. Like entire output 2, 3, 4, 5. Actually, it's not that fast, but like under 8 seconds, and that is a lot of possibilities. And we can get rid of a lot if we get rid of trailing dots and stuff. We could definitely do more. There's not that many. I mean, there's some trailing dots, so that would definitely do some other stuff. But okay, happy with that. Feet day 12, and yeah. So thanks for bearing with me on the first part of this video, which for me was yesterday, for you was 10 minutes ago. I was just all over the place. Alright, cool. Thank you for watching. I'll see you in the next one.